like I'll keep opening the same tab over and over again, and then I'll look at my like whatever like bar, and I'll see that like half the tabs are the same website. I'm like, oh, this is kind of wasting my time. Yeah,
We're live.
Cool.
we're live. Wow.
We're doing it.
Yeah. Welcome to the pod.
Thank you.
I guess we should intro you. Our guest today is Sam. Sam is a PhD student at Carnegie Mellon, working with Andy Pavlo on databases and some other professor whose name I forget, who does programming languages. Todd Mowry, the famous Todd Mowry. Yeah. Sam is from Australia, and
We're in Australia.
Sydney.
Oh, good. Because if you had named any other place aside from Sydney or Adelaide, I would have had to pretend like I knew where it was.
Well, you know Adelaide, so there you go.
I don't know where Adelaide is.
I only know it because of the CGP Grey Brady Herring podcast. Hello, Internet. Yeah. Anyway, sorry.
That's it. That's everything I know. That's the intro.
Wow. Amazing. Amazing.
And I do databases.
Yeah. And this databases, user-defined functions, especially.
What are user-defined? I mean, wait. I know what user-defined functions
Oh,
are.
really? Okay, that's great.
I know it's like
done.
from the name I can infer, but what is it more than that? I'm sure.
No, it's pretty much exactly what it sounds like.
Wow.
So if you have some, normally in a database system, you have to use SQL.
Okay.
But sometimes you want to do cool stuff in other programming languages, like in Python. So you can create a Python function, a user-defined function, which gets stored on the database system, and then you can call your Python function from your SQL queries. So for example, if you want to call an LLM as part of your SQL query, you can just create an LLM UDF and then call that.
I see.
Yep.
All right. Pretty exciting.
It's a way to escape the purity of relational algebra.
Exactly.
And jump out into terrible, Turing-complete programming language land.
Right.
It's a PL researcher's worst nightmare.
I see.
Yeah.
But yeah, the machine learners are creating a lot of
I was about
scenarios
to say,
and
that's my
databases.
bread and butter.
Yeah.
Everything just full, all machine learning. That's what me and Joey, my advisor, were talking about the other day of like, you know what? Let's close the human in the loop. No humans in the loop. It's all like an LLM will write your paper. It'll come up with experiments. It will run those experiments. It will determine whether or not it's a good paper. Then they'll have an ensemble of LLMs that will review it. And then we just paper generator.
Nice.
Yeah.
Putting ourselves out of a job. I like it.
Yeah.
Well, what I'm wondering is, if you're the person who came up with that, and then you publish all these papers, but you obviously don't say that they're fully LLM generated, and then you go on the faculty market, and then you you let it be known, these were actually all generated by LLMs. Would people be impressed, or would you have tanked your career?
I'm
That's a
going
good
to say the
question.
latter.
I think conferences now are adding clauses, so you're meant to submit and sign something saying, oh, if I'm submitting, I didn't use generative AI.
Yeah.
So you probably don't want to give away your secrets.
Yeah.
It's like not only is it fraud, but you've made everyone in the process look really bad. Like all the people who
But it's disruptive.
thought your papers were good and hired you, everyone.
It could still be good, right? But sure, fair enough. All right, so you're from Australia.
Yep.
Where did you do your undergrad?
University of Sydney.
Okay.
In Sydney, in Australia.
So you grew up in Sydney as well?
Yep.
What was it like going to school right where you grew up?
Well, I didn't live in the, right in the exact area where the university is.
Yeah.
But it's pretty common in Australia. Everyone is clustered around these big cities, and you don't move to some other city for college or uni, as people say.
I see.
And most people live with their parents during uni because it's so expensive, because the rent is really, really high. Maybe it's similar here, but
sure.
Yeah. Whereas in America, everyone just moves for college.
Right.
Yeah.
I've heard that dorm system in America is actually pretty specific to America. My friend from Australia says, you live at home. And also in Europe, I think that's the case, where you live in apartments throughout the city, but not exactly these concentrated dorms, which is so essential to, I think, the way Americans think about the college experience. It's kind of crazy that everyone else is not doing that.
Yeah, it's quite surprising to me. But
I never lived in dorms, but I hear it's great.
yeah, well, you were a freaking wonder boy, go to college when you're a young lad. But I had a nice 1 year dorm experience. Yeah, pretty good. And then Berkeley kind of kicks you out, but yeah, still fun.
Interesting.
Do you wish you had lived in dorms? Like, do you watch movies about college and think, wow, amazing?
Yeah, I think that in Australia there's a lack of, I don't know what it is, social life on campus because of this. Yeah. Because what happens is 5 p.m. comes around, you finish all your classes, and then everyone just takes public transport back home and eats dinner with their parents.
Yeah.
Like there's no concept of, oh, we're going to go out, we're going to have fun, we're going to stay up and do this thing.
Yeah.
Yeah.
Yeah, it's like a job. Like,
yeah, almost.
Totally bizarre.
Yeah.
Yeah. That's how I often describe, I guess this is an extreme version, but like when I would visit like MIT or something, they like live in the dorms. Most of them live in the dorms for like all of their college career.
Right.
And I feel like that vibe feels much more like a summer camp. Whereas at least in Berkeley, when they kick you out after your first year and then you just live off campus, it's like it feels much more like a 9 to 5 where your 9 to 5 is going to school. But I guess that is actually even more of a 9 to 5.
Yep.
And so this is why you got into database research. You're like, nothing better, no parties to go to.
Yeah, maybe. Maybe in hindsight, that's why.
Yeah.
Yeah.
When did you get into just research in general?
Yeah, so I guess I got into research very late compared to most people, at least most people I've talked to in the US. So in Australia, we have this weird British system thing called honours, which is like a 4th year of your degree where you do a year-long research project and write a thesis.
Okay.
Yeah. And I was taking this compilers class, and I thought compilers were really cool. And then there was this professor who was doing research on a Datalog compiler. And I was like, well, I like compilers. Do you have any projects? And he said, yes, I do. I have this cool project. And then I did a year-long research project on that. And then through that, that's how I realized, okay, yes, this is a compiler, but actually Datalog, it's really similar to SQL. So it's basically like a database. And it was interesting because when I first took my database class, I think it was in the 2nd year of my degree, I thought it was the most boring class ever. Ever. I think I was falling asleep in the class.
Damn.
I couldn't even find the energy to study. We were covering things like normal forms. Oh my. Yeah, it was terrible.
How many IOs?
Yeah.
Was that taught by Alan?
I think it was someone else that year. But yeah, like, it was super dry.
Alan?
Alan's a database researcher at University of Sydney.
Yeah.
Who, he did a sabbatical here in Berkeley, so he's been by the lab.
And presumably a boring lecturer.
Well, I've never seen him. But I was just curious if I knew. I could picture you falling asleep while he's lecturing, you know?
I think he's a really good lecturer. But the material is just so dry.
Yeah. I never took undergraduate databases, so.
Consider yourself lucky.
Yeah, I was not the biggest fan of I mean, I didn't hate it, but it was, for some reason in Berkeley, the undergrad database course, I don't know if it still is like this, but it's online. It's like the only CS course that was online before COVID. I don't know why.
Was it
That's
like
strange.
of Joe? Like recorded lectures? Or?
Yeah, there were recorded lectures. I think when I took it, there were live lectures, but just not a lot of people went to them. I don't know why it was online, but
I know for a while there weren't many people who could teach it. Like they recently hired database faculty, like they hired Natasha and Alvin and Aditya.
Yeah.
But for a long time it was just Joe, I think.
Okay, that makes sense. Yeah.
Interesting. So yeah, I hated databases, and now I'm doing a PhD in one. So there you go.
I didn't know you were a Datalog guy. That's exciting.
Yeah.
You have a lot of Datalog around here.
Can someone explain to me what a Datalog is?
Just think of it as SQL, but you have recursive queries.
Okay.
Its roots are in
The PL.
logic. Like, so it's like if you think of databases as like, what can you do with first order logic over data?
Yeah.
Datalog was like, what if you also have recursion on first order logic?
Okay.
But in general, that's like not guaranteed to terminate. So what if you restrict it so that the queries always terminate? So it's like much like relational algebra, like a very constrained and clean to reason about and like easy to optimize language.
Okay.
Yeah. So I was working on this Datalog engine called Souffle.
Okay. Amazing name.
Yeah. It's meant to be because you start with a bit of knowledge and then you apply these Datalog rules and progressively like get more knowledge until you stop. So it's kind of like baking a souffle and then it's ready.
See.
It's a pretty
That's
fun
nice. Yeah.
Yeah. So, I mean, the idea behind this project is that some tools or like pieces of software are just really naturally expressible in Datalog. So bug finding tools, like some networking applications, decompilers, this kind of stuff. So from a PL point of view, Datalog is kind of nice, but for a long time, like it wasn't really feasible because Datalog is just so slow, right? There hasn't been enough attention to optimizing Datalog queries. So then this project came out of Oracle Labs in Australia. And the idea is what happens if you compile Datalog to C++ programs? And if you come up with a good enough compiler, then the user can write Datalog programs, but instead of them running slow, now they run really fast. So it's kind of like a compiler's problem.
I see.
Yep. I feel like Datalog is kind of like the epitome of like declarative programming. Like people talk about SQL as declarative, but it's like kind of
A lot
like
of it
algebraic-y, whereas Datalog is like in its like theoretical form, it's just like logical formulas. And you have a list of formulas which are rules.
Okay.
And the like semantics of Datalog are take this list of rules and keep applying them until like nothing changes. So it's like this rule is like add this thing to the output, and this rule is like add this other thing if that thing's there. And you just like keep reapplying them again and again and again until it converges. And it's like
what does convergence mean in this setting?
Like the idea is you have some initial base of knowledge called facts. And then the rule.
Is there an example here? Like, is there like a? I mean,
yeah. So, like the most classic example is transitive closure, where you're just trying to find all the paths in a graph.
Okay.
So your initial set of facts is your edges, the edges of the graph.
All right.
And you can do something like, okay, well, I have a path if there's an edge, right? So that's one rule. Another rule would be like, okay, well, there's a path if there's another path between two nodes and there's another edge, right? Then you can extend that path by an extra edge. So if you just repeatedly apply these rules, you're going to get all the paths on the graph and then your program stops.
I see.
Yeah.
Okay.
That's a classic example. Yeah.
But it's a controversial topic whether people like writing Datalog programs who are just specifying rules and saying like go.
Wait, why is this controversial?
So like really declarative. Like you're just declaring the rules. You're not, it's anti-imperative programming.
Gotcha.
Yeah, it takes a lot of adjustment to think about writing code in Datalog. And it's also not super nice from a usability point of view to write Datalog. Like SQL is so Englishy.
Yeah.
So it's not too weird to write. Datalog is just pure logic. So it's very strange. And it's also recursive, which is a whole other thing. Yeah. So it's like really clean from a theory point of view.
Yeah.
But it's not super popular from a practical point of view.
There's a startup where you can use it for AI. So if you want to pivot your research into computer vision using Datalog.
Oh, beautiful. Yeah, I've been looking for that, actually.
Yeah, relational AI, check them out.
Yeah, a lot of the people from my lab who graduated are working at relational AI now. So
they're great folks.
Yeah.
They have an office in Berkeley.
Oh, cool.
Wow.
I didn't know that.
So, tell me about your advisors.
Well, so one advisor, his name's Todd Mowry.
Okay.
He's a professor at CMU, and he's really interested in compilers.
Okay.
So how do you get a program written in some language and run optimizations on it so that it can run faster, right? Pretty classic. He's a very chill, mellow guy. Then there's Andy Pablo. And he is an interesting character, to say the least. And yeah, so he's known for many crazy stories and many antics.
Mhm.
Yes. And
I showed Lisa the video where he's doing like the pretending that it's like LeBron James picking what school to go to.
with
which
TANU?
like which grad school at TANU go to.
Yeah.
And the first time I ever met TANU at a conference, I recognized him as like the guy from that video.
Yeah.
It was,
Yeah.
starstruck moment.
Yeah, truly.
So he wants to recreate that, except in the first video, he faked that there were important people in the audience.
Yeah.
Like the ambassador or whatever, right?
Mhm.
Whereas this time he actually wants to hire the mayor of Pittsburgh to show up. He wants to up the
You
stakes.
can hire the mayor of
I
Pittsburgh.
don't know.
I mean, what
I
else?
was gonna
is there?
try.
Yeah.
Yeah.
The mayor of Pittsburgh can't make that much money, right? Like I'm sure
Yeah.
he needs a side hustle.
Yeah. So
What could be more important than this? I don't know what could be.
yeah, this is true.
Yeah.
Yeah, I do feel like Andy is, in my view, like if I were to be a professor, that's a great vibe.
Mhm.
Like I would love that vibe of going a little bit too hard into not really research, like just I don't know, really strong personality. He
Hmm.
seems. I've never met the guy though.
You're exactly correct.
Yeah. What are like your research meetings like with him?
Yeah, it's a good question. I think that he's very focused during our meetings,
Mhm.
and there's no antics.
I see. That's a little disappointing.
A little bit. But then when it comes to things like paper writing
Mhm.
or presentations, then it's full antics.
Nice.
Like, what jokes can we fit into this
Mhm.
paper? What jokes can we fit into this presentation? So he had a paper where he tried to get a poop emoji in the title, but then you couldn't write a poop emoji in LaTeX, so he gave up on that.
Right. Right.
And he had a paper rejected 3 times because the name was just too ridiculous.
What is
Yeah.
that grounds for rejection?
Like, they wouldn't let him get the paper through. And they had these back and forth with the reviewer.
I see.
Yeah.
Sam just gave a talk at Cider where there were some good bits in there about how Andy wouldn't let Sam have a girlfriend, so we have to focus on databases.
Damn.
And I mean, that takes up too much time, right? If I'm serious about databases, I'm going to have to
Yeah.
live the single life.
Yeah, I had a there's a researcher who will not be named, but he is quite infamous in the Berkeley AI group for having, I think, the highest paper output anyone has ever seen. And I heard from a friend who is friends with him that one time we like went out to lunch and he was like, "Oh, yeah, I remember my first year, like I was dating someone and I published like no papers. But the second I broke up, like I had so many papers. So I really would just recommend holding off on a relationship."
Wow.
Yeah.
Maybe Andy's onto something.
Yeah, truly.
He had a girlfriend all throughout grad school, though.
Yes.
And he's mad. Maybe he regrets it. Maybe he's like, wow, my output could have been
Right.
just through the roof. Exactly.
Damn.
Yeah.
Mm-hmm.
Yeah. So, second year,
Yep.
is it better or worse than your first year?
Yeah, it's a good question. So I think that in the first year, I really didn't know what I was doing.
Mhm.
And there was a lot of adjustment of learning how to work with your advisors.
Yeah.
So that was rough.
Mhm.
But I feel like in the second year, it's a lot more chill, I feel.
Interesting. I feel like a lot of people report second year is the worst year of grad school.
Yeah.
I mean, for me, the first year was very fun. I definitely hadn't like figured out how to do good research, but I guess I just wasn't putting pressure on myself too. And then second year kind of hit like, well, I haven't done anything, but I wish I had. So now that's going to come to a head, I guess.
Yeah.
Um,
So, you're co-advised.
Yep.
What is the co-advised relationship like? Like, I know some people, their co-advisors talk to each other a lot. They'll have joint meetings, and some people are like, it is two separate relationships.
Yeah, so my understanding is that co-advising when you're sort of just doing separate projects with both is very, very challenging. And the people I know who've done that have sort of been doing 2 PhDs, one with the first advisor, one with the second advisor, and it's tricky. In my case, it's sort of like what I'm doing is exactly at the intersection of databases and compilers. So I sort of need someone from both sides to be able to really work on this and do a good job. I always have joint meetings. I tried doing like separate meetings. That didn't work because the other meetings would just be repeating what I said from the previous meeting. Yeah. I think co-advising is super good because you don't have one advisor who says, this is how we're going to do things. You have to do it this way.
Yeah.
There's more of a discussion and there's more room for doubt. Yeah. That's my sense about it. And it's also good because one advisor might be really good at one thing and another advisor might be really good at another thing. And you get to take the best of both.
Yeah.
In fact, one of my advisors, Todd, he only co-advises.
Really?
Yeah.
I guess, I don't know why I was so surprised. One of my advisors is also kind of like this. I think he solo advises maybe one student. Yeah. I considered going back to, I had a few joint meetings like throughout the years, but it's never stuck. I think mostly for scheduling reasons.
Right.
But then sometimes it's just like, I feel like for every project, maybe this isn't for everyone, but like one advisor will just be more involved, whether it's like time or interest. And then it almost feels weird having joint meetings because like one person's kind of out of it, like they're not as interested, and then one person is really interested. So I'm like, I feel like I'm wasting this other person's time.
That makes sense.
Yeah.
I just really like one-on-one meetings. Like I really, as soon as there's like 3 people, I feel like the conversation's kind of like dart in one direction or another. Like, one-on-one, it's like very high throughput, or high bandwidth.
Yeah, that makes sense.
Yeah, one of the professors I started working with was like, I don't do joint meetings, which I thought was quite interesting. I think I don't know, there's some trade-off. The issue is that I would then need to remember everything that we've said to relate to other people, and I'm historically quite bad at this. But I guess hopefully I remember only the relevant bits.
Yeah, I think co-advising can be a win, but you have to do it right. Yeah. It's not easy.
So what's the group vibe at CMU? I heard CMU has a like very different setup, whereas Berkeley's like open lab, CMU is more office based.
You're exactly right. Yeah. So this whole thing of like, oh, there's a lab with 60 or 80 PhD students is just totally non-existent at CMU. So in fact, a lot of times labs are just one professor and their students, and maybe it's like 4 or 5 students. It's very, very different. In fact, before recording, Connor and I were just talking about the fact that these sorts of meeting rooms, not even a thing at CMU. Yeah, like everyone just has their own office. I mean, offices are shared by, say, 2 or 3 PhD students.
Yeah.
And the whole floor is just offices. So there's not an open space. It's like very much meetings with your advisors. And it's more like working with your advisors directly as opposed to working with other PhD students. Yeah, so very different dynamic.
Yeah, I don't know. So my inclination is to be like, oh, that's objectively worse. And I remember when I was in like, I was heavily considering going to CMU, and one of the main turnoffs was this like office setup.
Yep.
Like I thought, oh, this would make it so that it'd be harder to like have friends, and then it'd be harder to like collaborate, explore. Do you agree or disagree with this sentiment?
Yeah, it's a really good point. So, at least for me, most of my friends are not in my lab. In fact, almost all of my friends are not in my lab.
How'd you meet them?
So, we have this thing where when you start grad school, we have like an orientation where we hear talks from all the faculty trying to recruit students. and you meet all the other students.
Mhm.
So through that, you meet people in your cohort, you meet older students, when you've been around long enough, younger students, and these larger groups emerge. And it's really nice. Like people are very social, and that's really fun. But it's very separated from the research.
Yeah.
Whereas at Berkeley, I guess, because you're working so closely with people, you gain more friends through your lab. So it's different.
Yeah.
Yeah.
I'd say that's definitely the case. So it seems like one thing I've noticed is like when a lot of your friends are in your lab, like it's easy to fall into like you only hang out at work sort of thing. So at CMU, do you think it's more of a...
It's the opposite.
That's so cool.
So what happens is like people do work. Maybe what will happen is you'll work from your friend's office because it's like sometimes boring to work by yourself.
Right.
And then after, I don't know, 5, hey, do you want to grab dinner? Oh yeah, this person's around. Let's go and grab dinner. And it's more doing stuff together off campus. Yeah. And it's strange, but we almost never talk about research.
Wow.
Yeah. And I think a big reason for that is that people are just spanning very different areas.
Yeah.
So people do theory, graphics, PL, databases, and because you know that the other person doesn't know that much about your research, you just don't talk about it.
Right.
That's very interesting.
So it's
healthy.
Yeah. So it's kind of fun. But at the same time, there are still people in your lab if you do want to talk about databases or your research area or whatever. So I think it's a good mix, but it's hard to explain. You're definitely missing something compared to having a huge lab.
Sure.
Yeah.
How is the social scene? Like how do people hang out? What do people do? CMU grad school.
Yeah, I mean, there's definitely a lot of like going out for dinner, checking out different places nearby. There is stuff like people go for karaoke or go to like a concert or a club or whatever. But I don't know. It's different from being in a like proper city where there's a lot more things to do.
Yeah, I'm surprised here Pittsburgh has many clubs.
Yeah, I mean, I wouldn't say there's many, but there's some. There exists clubs in Pittsburgh. Let's leave it at that.
Heard it.
Yeah.
What's the club vibe in Pittsburgh? Would you say it's good? Is it all CMU students?
No. I think it's the opposite, actually. So it's like this weird thing where Pittsburgh is somewhat gentrified with a lot of new people moving into the city. And because of that, there are some like hip new places in Pittsburgh. So that's sort of, I don't know, it's very different than what you'd imagine Pittsburgh to be like. Yeah. But I think it's just like a different vibe than in a big city. Yeah.
So you say that you and your friends want to talk about research.
Yeah.
But do you like bitch about your advisors? Like, do you talk about like grad school in the abstract?
Yes, absolutely. You kind of have to.
Some things are the same everywhere.
Because actually it's like you can't, your advisors you obviously can't talk to about it. The people in your lab, you can't really talk to about it. I mean, some stuff you could. For example, like I was trying to talk to my advisor about this, but they didn't get it.
Yeah.
Oh, try this. But if you really want to like, I don't know, gossip.
Right.
There's no way that you can drop those kinds of bombs
Well,
in your lab. At least
not safely.
Not safely, yeah. So yeah, there's a lot of that.
And how would you say, I mean, I guess it's hard because people don't tend to talk a lot about like, oh, my advisor's so great. But how would you say? Maybe you do, I don't know. But how would you say the advisor satisfaction rate is at CMU?
At CMU? I'd say very high.
Really?
Yeah. There are some cases where people don't have such a good time.
Right.
One thing that's super good about CMU is you're guaranteed funding independent of your advisor, so people switch.
Oh.
Yeah. So that is a really good perk, and I know people who've done that.
Switch like late into the PhD?
You could switch later. Usually it happens earlier because these kind of interpersonal issues, which is or lack of motivation for a specific advisor's style of research, usually these sorts of problems manifest earlier.
Yeah.
And people switch. It could also just be that people know that they can switch, so they're like, oh, I may as well just switch now.
Mhm.
Yeah. So the people I know, they usually they've switched after maybe around a year.
Berkeley technically has a system where you're able to switch in the first year, and their funding is through the department or guaranteed by the department at least, although I think you are still getting paid out of professors' specific research grants. But in practice, people don't switch that often. So.
Yeah. I don't think people. I mean, at CMU, technically, you come in without an advisor.
Yep,
right?
exactly. Wow. So in the first month, you're meant to match,
Right.
which can be a stressful process for a lot of people. So the way they do it is they call it IC, the introductory course, and every single faculty who's recruiting students gives a talk about their research, and it's actually super exhausting. Listening to endless research talks, which are not even necessarily presented very well.
But then those are the people you don't want to go to.
There you go. Yeah. So you spend all this time listening to talks, and to be honest, for a lot of people, they know kind of who they're going to work with.
Right.
So for me, I'm interested in databases and compilers, and up until recently, there's one database professor and one compilers professor. So it's pretty clear cut who I'm going to work with. But for a lot of people, they're going in and they're not super sure, especially if they're in larger fields like ML. So this process gives them more room to switch. And there's a lot of cases actually where people have switched to super different areas. So they come in wanting to do PL, and then they end up doing queuing theory or something like that. Yeah.
So you came in kind of knowing who you wanted to work with.
Yep.
Was it still nerve-wracking?
Yes.
To be like, hey, Andy.
Yes. Yeah. So it was very nerve-wracking because Todd told me he would 100% take me.
Oh.
But Andy did not. So it was pretty nerve-wracking because I arrived and I didn't know for sure whether I would actually be able to work with him.
Right.
So it's kind of high risk. But yeah, we ended up working it out. So
did you do any elaborate antics to
No.
like a simulated proposal?
Right.
Nothing.
Staging my own death.
Yeah.
It seems like you would have appreciated it.
Yeah.
I really think that I haven't lost this idea of when you want to start a collaboration, you do a promposal. I don't know if you're familiar with this concept. I feel like this needs to happen. Maybe.
I mean, I did something similar.
Really?
I mean, I wouldn't call it a prompose, whatever the term is. But I was just like, okay, here's what I want to work on. I think it's pretty interesting. Let's do it. And then he was like, okay, sounds good.
Wow. Amazing.
Yep.
You've had this promposal idea for a while.
I know.
I didn't see anyone do it.
I know. I need to do it. I just need to find another collaboration, which I guess is not that hard. Well, but yeah. Anyway, have a nice poster board. Have someone with a portable jukebox in the background. Be pretty good. So speaking of antics, do you like doing them?
Oh yeah, I mean, I'm open-minded towards it all. I wouldn't say that without Andy I would be doing these things, but he can convince me.
I see.
Yeah, so he had a previous PhD student who was presenting at a conference, and his conference talk was not super exciting. It's very technical. And Andy was like, all right. So I went to the shops and I got some fake bandages, a knife, and blood. So I'm going to put these bandages around you, stitch you up with fake blood, and you're going to hold the knife in, and then you're going to pretend that you were just stabbed by your ex-wife. Go.
Wait, what? I'm so confused at the context.
In the middle of the talk?
Yeah.
Right before his talk. So then he goes up, and he's like, oh, sorry guys, coughing a bit, I'm not 100%. It's because my ex-wife stabbed me. We got in this big argument. Yeah, I'm bleeding everywhere, but it's fine. Let me get this talk.
Wow, that's
And then everyone remembered that talk and remembered what it was about. So
we're amateur hour over
Yeah,
here.
goddamn.
I'm like very embarrassed.
Yeah, wow. I really thought I was going out of the box with my last talk
Mhm.
when I made a joke about, since I'm giving this talk in the morning, I got the advice of figuring out what my main takeaway was,
Mhm.
putting it in big letters in a big box, and making it your first slide.
Yep.
Cut to. So boring. Dude, I should have had, forget what president it was, but he was giving a speech, and then someone shot him, and then he can, just finish the speech.
I should have done that.
Exactly.
Like stage someone to shoot.
Yeah, stage an assassin. Just actually recreate that.
Hire someone from Craigslist.
Or just a friend.
I see. That might be cheaper.
Yeah, and ideally it would not be a real gun. I would prefer that, but
Write that down.
Write that down. I mean, I guess it's recorded.
Yeah.
So you're in databases.
Mm-hmm.
Do you think you're going to be in databases for the rest of your life?
Yes.
What? Damn.
100%.
Why?
Wait, what do you mean why? Okay, I guess I'll elaborate.
Yeah.
So I was in compilers forever, for a really long time.
Mm-hmm.
I did compilers for my undergrad research. I work at Apple doing compilers. And the problem is that with compilers, people spend so much time trying to squeeze the juice of 0.1% faster. And so much work has been done to try and make things faster, but there's just no room to play with. Right?
Okay.
And the reason why is because at the end of the day, it's like C code or whatever. How do you make a C program run faster? And so many people have thought about this, and no matter how clever you are, there's not much room for improvement. But databases, you have so much room to try different techniques to make it faster. There's always something new that you can come up with. And the other thing is that there's just so many databases. Everyone's using databases. Every single website is basically backed by some database. And then you see all of these connections between the research community and the industry, where someone publishes a paper, and then this company is like, yeah, we implemented that paper, and it's so much faster now. And you see this all the time. There's such a close, tight-knit relationship between the academic database community and the industry database community. And things are dynamic and changing, which keeps it exciting. It's best.
Wow.
I'm inspired.
I am, truly.
Yeah.
So, follow-up question. Do you ever look at the data in these databases?
Yeah, of course.
Okay. I didn't know if database researchers actually looked at data or if they're just worried about runtime or something.
I mean, that's how you come up with tricks, right?
You tell me.
Yeah, well, a lot of times you can use that to make the queries run faster. You can say the data, there was just some talk we were listening to, which is there's a lot of repeated data. Maybe I can use compression, right? And then if I compress the data in this way, I can execute it way faster. So you're kind of exploiting the properties of real-world data sets to make queries run faster.
I see.
Yeah, a lot of ideas can come from just looking at the data and seeing what cool tricks you can do.
But it's not like ML where it's wow, these cat pictures are so cute in this data set.
So, I mean, that is tragic.
Or we're not using the whole range of these floating point numbers.
Yeah.
We could exploit that.
Yeah, it's not as fun, but
Teach their own.
yeah. So, if databases, it makes what you're saying makes a lot of sense. And it makes me think that, do you feel like you know these benchmarked? I'm assuming these are all benchmarks of real world workloads or something. Do you start with the benchmark and then come up with the method, or vice versa?
Yeah, it's a really good question. So different researchers do different things. And sometimes with benchmarks, it doesn't capture exactly what you want. So for example, there's a lot of these classic databases and benchmarks that have been around since 1990s or something. Yeah. And obviously data has changed since then. But, new benchmarks come out all the time. A lot of times companies will publish benchmarks to motivate researchers to improve performance for those kinds of workloads.
Mhm.
So I guess my advisor and myself, we're sort of in this camp of you want to build something and measure and then find opportunities through that, sort of like systems building as a first-class research activity.
Okay.
And the reason for that is it's really hard to figure out what might be the problem just by thinking about it. Only when you build the system and measure it are you going to know for sure. And it's never what you expect. Never.
Yeah.
Yeah.
Very pragmatic approach.
Yeah. Whereas other researchers, they might say, oh, well, maybe we can create a prototype, a very small example, and think about maybe where a technique could be applied. But the challenge there is, how do you know that you're solving a real world problem?
Mm-hmm.
So it's sort of this question, and but the advantage there is you don't have to build a whole system.
Mm-hmm.
So you can maybe expedite the research process, write more papers. But the challenge there is maybe impact. How do you know you're working on impactful stuff?
Yeah. Yeah, I feel like that's in the systems community, that's a pretty big, do you build the system and focus on almost the software artifact usability of it, or do you focus on the theoretical side?
Yeah, we're very familiar with the impact versus research papers dichotomy and
so true.
Yeah, that's a very common.
What is this
topic of discussion? Just the question of what is impact? What is the goal of research? Is it to write papers? Is anyone going to use this stuff? Is the goal to start create open source artifacts, or to get your ideas into real products, or start companies with your ideas? And I think a lot of people at Berkeley fall on different points in that spectrum, but we see pretty much every point in that spectrum.
It's definitely the same at CMU. So, for example, I was taking a computer architecture class, and then the professor, so I was like, oh, most of these papers haven't been implemented. And he said, I don't particularly care what Intel chooses to do or not to do. And I was like, wow, okay.
Yeah.
And I think his perspective is just that, at least in his community, computer architecture, it's about exploring different ideas and approaches, and the good ideas eventually win out. Yeah.
I think there's something to be said for just because something is getting used doesn't mean it was the right solution.
Definitely.
Sometimes this is the result of marketing, or just you knew a guy at Google who was willing to implement your paper, or we're just bad decision making. I don't know. Mike Stonebreaker has this thing about industries where rubber meets the road on research. But it's not.
There's more to it.
It's not a ground truth necessarily, but it is a good signal that you did something that was useful.
So when you're focused on building the system first, do you ever run into this problem where you're is this even research?
Definitely. Yeah. So what I've been doing is working on an existing system called DuckDB. And then, great. I mean, most people haven't heard of it. And, I was trying to implement some papers, right? Just run the state of the art in that space.
Yeah.
And then I ran into this problem where my queries wouldn't run because the developers of DuckDB just didn't implement that feature. So I spent 3 months implementing it myself, and now it's in DuckDB. And that 3 months was really, really tough and tricky because you have this huge code base. There's not much documentation. It's really tricky. But now that I have it and it actually works, it's made everything after that so much easier from a research point of view. I can just try things, measure things, see what's going on. But definitely during that time period, it can be frustrating because it's I really just want to do my research, but now I have to put on my engineer hat and just be an engineer. So it's sort of I don't know what the word is. Not doing the thing you signed up to do, but at the same time, it's a necessary part of the process. Yeah. So one thing I heard actually is you mentioned that there's a research engineer in your lab. Is that right?
Yeah, in the Hydra group specifically, yeah.
Right. So it's interesting because Andy was saying, "Oh, we can't afford an engineer."
Yeah.
But you can afford to pay the mayor of Pittsburgh to come
Well,
here.
you know, that's a different story, right?
Most groups at Berkeley do not have research engineers.
Right.
The being in the Bay Area lends you certain funding opportunities that aren't always available to computer science departments, and I think it's a pretty like exceptional situation that Joe is able to get enough money to pay a research engineer like a non-grad student sort of salary, like something that you could actually attract someone from industry to do.
Right.
Like that. And
Yeah.
Engineers make a lot more money than grad students.
I know. A little bit more.
Yeah.
Yeah, so what I was going to say is this is the sort of thing that would be really nice to have a research engineer do.
Mm-hmm.
Now, there are undergrads and master's students, right? And they're a bit cheaper, meaning free, than hiring a research engineer.
They pay you in some cases.
Yeah,
Exactly.
But yeah, the problem there is a lot of people are trying to gain experience. They're not coming in with a lot of experience. So it might be hard for them to do stuff. Yeah.
Do you have undergrads?
Yeah, so I have an undergrad right now and a master's student that I'm working with.
And how has that experience been?
Yeah, it's good. I think that different undergrads or master's students, whatever, they have really different goals. And it's really tricky sometimes to figure out what the right thing to do is in terms of projects for that person. So some people just want to learn engineering skills. So we would more like work on the implementation of an idea, and then they would put that on their CV, apply for jobs, and then that would be really helpful. So actually the thing I was describing earlier for DuckDB, I actually did that with 2 master's students. They both got really good database jobs. One is actually working on DuckDB at this company called MotherDuck, which is like the commercialization of DuckDB. Whereas the undergrad that I'm working with right now, he really wants to get research experience and apply for grad school.
Yeah.
So instead of thinking like, oh, here's an engineering problem, maybe you can help me with that. It's more like, okay, what's a research problem that could potentially end up with a paper that would look really good if you were applying.
Yeah. And
there's different, I don't know what the word is, mentoring skills necessary for those. So with engineering, most of the mentoring skills are like reviewing their code, showing them like tips or tricks to do things better. It's almost like a software engineering internship in some ways. Whereas with research, the mentoring is really different. It's more like, oh, well, like what would make a good research paper? Like what's a really good idea? Or how should we pitch this? Or like, what's the fastest way that we can check whether this idea is going to work or not? So it's 2 entirely different skill sets, I would say.
Yeah.
Yeah.
Yeah, I definitely see that difference as well. Like what students want to get out of undergraduate research is really different.
Yeah.
Are you glad you went to grad school?
Oh yeah, absolutely.
Is this a common path from like computer science in Australia? Do a lot of people come to America and go to grad school?
Absolutely not. Absolutely not.
What would you say like most people from your bachelor's degree program ended up doing?
They're working as a software engineer back in Australia.
Okay.
So like Google, Amazon, Microsoft, Canva, Atlassian, these sorts of companies in Australia. Yeah. I mean, a lot of people have family and friends and, you know, it's a very nice life there. Weather is super good. There's like really good benefits, like lots of paid time off. The work culture is not stressful whatsoever. So if you're a software engineer here, like you're expected to deliver a lot because it's a very competitive landscape, right? Whereas in Australia, like it's pretty chill by comparison. If you're working after 5, people will be like, why are you here? Go home.
I see.
Right? So yeah, I mean, most people wouldn't leave. There are some people who do. A lot of people actually go to the UK, like Oxford or Cambridge or something like that. But yeah, I mean, if you want to do systems research, you're going to struggle to do that outside of maybe a few groups in Europe. I mean, mostly all the action is happening in the US, so it was pretty clear cut. Yeah.
You were like, for sure you want to do a PhD, for sure you want to do research.
Well, it's interesting because after my first research project, I said, I'm never doing research ever again. Yeah. So the story behind that was that I was working on this problem to make this like Datalog compiler faster or whatever. And it was this really nice theory problem. There was like a bunch of lattice theory or whatever. It was really neat. And then I ran the experiments and it was like 1% faster. And then I had this meeting with my advisor and I thought, oh, well, I'm going to fail my thesis because I spent all this time coming up with this sick algorithm, but it's completely useless.
Mm.
And he's like, oh, of course it's only 1% faster. I'm like, what? He's like, yeah, you're running multi-threaded. I'm like, yeah, but everyone runs multi-threaded. My watch has 4 threads. Right? And then he's like, no, it's not a fair comparison. You have to run it single-threaded. And I'm like, why? He said, well, you see, your technique makes the CPU time decrease. When you increase the number of threads, it becomes a memory-bound problem. And then when it's a memory-bound problem, it doesn't matter that you're decreasing the CPU time. I'm like, okay.
So it's only working in a single-threaded situation.
Right, so I ran a single-threaded. By the way, even our regression test, like our test suite, runs with 64 threads. So anyways, so I ran it single-threaded and it's like twice as fast.
Mm-hmm.
And I don't know, I put that in my thesis, went really well, whatever. But I was like, okay, I've done all the work. I spent a year on this. And even if people are running like in the situation where we make it faster, there will be an imperceptible difference.
Mm-hmm.
Like, what's the point of this? And I just thought the whole thing was like a massive waste of time. And I was like, all right, now I'm going to do real stuff. And that's why I applied to work at Apple. And then at Apple, I had the opposite experience where you're working on the kinds of things where there's billions of users of Apple products, but it's so mind-numbingly boring to do that kind of work.
Yeah.
Like bug fixing, adding extremely minor features, dealing with spaghetti code bases with millions of lines of code, lack of documentation. And at that point, I was like, okay, well, clearly I'm not going to be super satisfied if I'm working on useless stuff. And I'm also not going to be super satisfied if it's completely mind-numbingly boring. So I'm going to have to find something that's both intellectually interesting and impactful. And it's like, well, systems research is the way to go.
Yeah, that's a really good fit.
Yeah.
So to me, like, I have never, ever, like, regretted it or been like, oh, damn, like, I wish I was back at Apple or back working on, I don't know, what I did in my undergrad. It's like, no, this is a really good opportunity.
How long were you at Apple before you left?
Yeah, so I was only there for 6 months. That was enough. And this was during COVID, so I was working remotely for the California branch. And that was tricky as well. But essentially they said, listen, you're going to have to relocate if you want to stay with us. And I was like, this is terrible. I don't want to do this.
Never in a million years when I went to California.
Just for this.
Unacceptable.
I mean, California is great. I would have moved. But the work was terrible.
Yeah.
The thing that was really scary to me, though, was when I was talking to my manager about it. And I basically had a meeting and I said, you know that what we're doing is bullshit, right? And then he was essentially like, oh, but you know, every compiler engineering role is very similar, where at the beginning, you work on all the interesting design problems and you have all those PhD people who know a lot about compilers doing the interesting work. Then they all leave. And then we're stuck cleaning up the mess and doing the minor features and bug fixing. And then he's worked in all the major companies that work on compilers. And I was like, okay, so clearly I need to get a PhD.
Yeah.
Yeah. I mean, it's not to say that you can't, with enough experience, get to a position where you're trusted to design a big project without a PhD.
Yeah.
But it's a massive uphill battle.
We're coming up on the hour. Should we do the lightning topics?
Sure.
It's one of our favorite things on the podcast. So we're just going to name hot areas in computer science and you give us your quick take.
Yep.
All right. Large language models.
I mean, there's a lot of hype around them. It's almost hard to say that they're appropriately rated, but I'd say they're a little overrated, but not that overrated. They're pretty cool.
Crypto.
Isn't crypto dead at this point?
This is your take.
I don't know. I think that there was a lot of buzz around crypto for a very long period of time. It somehow died down. Did all the crypto folks move to LLMs or something? Like, I haven't even heard about crypto.
I think there was a large migration.
Yeah.
Wow.
So I don't know if it's even overrated at this point.
It's just not rated. It's not there.
There's no rating of crypto at this point.
What about Datalog?
Yeah, that's tough. I think it's underrated in terms of theory, because there's a lot of really interesting work that's come out of that space. And sometimes thinking about your problem that way can really help. But I'd say it's massively overrated in terms of the impact and practical, like direct practical application of Datalog. So it's more like a useful theoretical tool, is what I would say.
What are your thoughts on the Pandas library?
I don't know that much about Pandas, actually. I've been told that it's a bad database the creator of Pandas gave a talk at CIDA.
Yeah.
He said he basically just taught a new generation of people to use a bad database and not use SQL.
What?
Yeah, Wes Kennedy gave it up.
Wow.
So he thinks it's not a good database, but I think there's something to it in terms of just being like a lot more intuitive and understandable compared to SQL. Yeah, and I think, DuckDB has a Pandas API, so you can program in Pandas for that kind of experience, but you get really good performance, like as if you wrote it in SQL. That seems like a pretty good solution to me.
Hmm.
So I'd say it's, I don't know, appropriately rated.
Okay.
Yeah.
You got quantum computing.
Yeah, that's a good one. I feel like I've been told that quantum computing is almost going to take off for the last 10 years, but it really hasn't. Yeah. I mean, I think that people are worried when it comes to the encryption, and a quantum computer is going to break traditional encryption. But I think there's already been a lot of work on like quantum safe encryption. So I don't know, if a quantum computer came out tomorrow, would we be that, like a really good quantum computer, would we really be that screwed?
Mhm.
Maybe, maybe not. And then it seems like the applications beyond like breaking encryption are somewhat limited at this point. So maybe a bit overrated,
Okay.
but we'll see.
Cool.
Yeah.
Well, it's been fun. Thanks for coming on the pod. Our first database person on the pod, I think.
Oh, really?
Also, our first non-Berkeley person.
Oh,
right?
true.
So,
yeah.
Really hitting all the new whatevers.
Mm-hmm. Yeah. Awesome.
Anything? Yeah. Is there anything you want to plug, or like where can people find you on the internet or anything?
Mm-hmm. Yes, I have a website, samarch.xyz. And I'm also on Twitter, samarchdb. So that's dedication to sticking with databases for the foreseeable future.
Wow.
Yes.
Love the commitment.
Yep.
All right.
Yeah.
Good to go.